Hello, Facebook students. Today, we are going to review algebraic properties. If you are taking beginning algebra or pre-algebra, intermediate algebra, or algebra 1, these are the properties that you need to know. If this is beneficial to you or to other students that you know, please like and share. Hope everyone is doing fine, staying healthy and safe. So good day to my Facebook students. Just going to wait until maybe a few people come on. And if you're looking at this later, you can always replay so you can review and have it in your notes if you're taking notes. Okay, so let's get started. Algebraic properties. I'm just going to go over them and try to give examples. I'm going to give examples along with the properties, so hopefully that you will understand how these properties work in algebra. All right, let's. Hey, Johnny, how you doing? I'm on live. Okay, the first property that we're going to put up is A plus B, okay, equals A plus B equals B plus A, okay? So this is for all real numbers. I don't know if you know, I'm gonna put for all real numbers. And you're probably asking yourself, what are real numbers? Okay, so let me kind of step back a little bit and give you the definition for real numbers before we go into this first property. Real numbers consist of numbers that are from 0 to infinity, okay? So infinity, that means it never ends, okay? So we can be in the billions, all right? From 0 to infinity are real numbers. But let me break it down a little simpler. You have natural numbers. So we got to figure out first, let's deal with our vocabulary. I'm really big on vocabulary. You're in definitions. Definitions, rules, formulas, terminology, vocabulary. You must understand that so you can understand what you're doing. So we're going to review what real numbers are before I put up the properties, okay? And I can tell you what this property represents. So just follow me in red because we're talking about real numbers. So the first one is natural numbers. Natural numbers. What are natural numbers? Natural numbers are equal to numbers that begin from 1, 2, 3, ... My ... represents to infinity. So just say if I just put infinity, it could be any number from 1 to 0. I'm sorry, from 1 to infinity, okay? You may not see that in a textbook, but the ... represent it continues to go on. The numbers never end, all right? That's for natural numbers. Now, whole numbers, I hope you can see my dry erase board. If you can see everything clearly, please wave at me so I know that you are seeing everything clearly. Just gonna step back so I can see. Please wave. Hi, Tatiana. Hi, Tina. Hi, Christine. Hi, Monica. All right, thank you. I just want to make sure my board is clear. All right. Please like and share if you believe it would help other students. All right, so let's go back to whole numbers. What are whole numbers? Okay, whole numbers are equal to This is a brace. Excuse my brace. Sometimes I can sketch it perfectly. It goes like this. All right. On to infinity. That means the numbers never end. It can be any number from 0 to whatever. Okay? All right. Now I have to erase this because I don't have enough space, so I'm going to erase this. So you can replay if you didn't catch this part. All right. So now let's go to integers. Integers are part of my real numbers. I'm going to erase this for right now because we're dealing with, so I can answer the question, what are real numbers for these properties? All right, so now we're at integers. Integers. Okay, integers are considered real numbers, and it's equal to, make my brace, okay, and we starting like dot, 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 because these are your negative numbers. So it can start from -3, comma, -2, comma, -1, comma, 0, comma, 1, 2, 3, dot, dot, dot. Here's my brace. Okay, so integers are still real numbers, but they begin with the negative number. So it's all the way to infinity, negative infinity. Okay, so it never ends. But look, integers include all negative numbers plus 0 plus your positive numbers. All right, so those are still real numbers. All right, now we have rational. Terminology. Okay, vocabulary. What are rational numbers? Rational numbers are equal to, so I'm going to just represent A divided by B. Okay, remember, A and B are some number that we don't know. So I'm just going to kind of put an example here. Okay, so just say rational numbers are basically they're fractions. All right, they are fractions. And A and B are integers. A and B are integers, okay? With B cannot equal to 0. A and B are integers. So what are integers? Integers can be negative numbers, including 0, plus your positive numbers. So that means A, and I'm going to write this in a different color so we can see this. A and B are integers, and it cannot equal to 0. So B cannot equal, I'm going to put, that means not equal. That's a not equal symbol. It cannot equal to the number 0. Cannot. Okay? Because anything divided by 0, you're not going to get it. Okay? So it cannot be 0. It has to be a number above 0. All right? Everybody has that? So these are your rational numbers. So this is why I explain what integers are, because A and B are integers, but it can't be 0. We can't have 0. All righty? All right, so just remember, rational means it's ratio. See the root word? Ratio. Ratio means fractions, okay? It is like A to B. Sometimes you may see it with the colon. A to B. That means A to B. Anytime you see anything written like this, it means it's a fraction. A to B, or A colon B, or A divided by B. Those are ratio. That means ratio. That means you're going to divide. Okay? All right, I'm going to erase this now. We're going to the last real number. It takes time when you have to break vocabulary down, because this is part of algebra, and sometimes students they bypass this because they don't want to read the textbook. And I know our teachers out there, they do review this because this is a major definition rule, and when we get into the properties, you'll see why. Okay, let's look at the last one. The last one is irrational. Hope I'm spelling it right. Irrational. That's irrational numbers. Irrational numbers are equal to okay? We have x. This is like x, and this is like saying in your intervals, okay? So x, that means x is included. I'm gonna write it here. X is not rational. You'll see it like this written in the textbook, okay? And they have to close it with the brace. So this little bar tells you that x is in some type of interval, but this number x, the variable x, because it represents some number, real number, x is not rational. And remember what rational numbers are. Rational means fraction. So that means x cannot, this number, whatever this number, this variable represents, it cannot be a fraction. Cannot be a fraction. All right? Okay, so let's move on now to our properties of the real numbers. So that's why I had to go back and give you the definition of what real numbers are. So when you replay this, you can write it in your notes and review it. All right. Okay, so now for all real numbers, we're going to use this in our properties. So the first property is called commutative. C-O-M-M-U-N-A-T-I-V-E. This is called the commutative property. Commutative property. All right? And what is the commutative property? It's when you say A plus B equal the reverse of it, B plus A. Now, I know I'm representing these with variables, but I'm going to give you an example so you'll see what it really means, okay? And A, you can have it for addition, and you can have it for multiplication. So let's do A times, I'm using my dot to represent multiplication, A times B equals B times A. All right, so let's plug in numbers, constants or numbers for this. So if my A is a 3 plus 4, then guess what? B now is 4. We're just flipping it. We're just doing the reverse of it. Plus 3. So all we're doing is changing the location of our numbers. So this is what the commutative property is. When they ask you, okay, they ask you to identify on a multiple choice exam or your test online, and you have to pick out, identify what a commutative property looks like. Well, this is how you do it. Okay, now let's do 3 times 4. That's A times B equals, now B is 4. 4 times 3. All right, all we're doing is just switching locations, switching your place. Okay. All right, let's move on to our next property. So this is commutative property, and now we're going to do the next property. I have to erase because I don't have enough space on the board where you can see it clearly. All right, so I hope you all are taking notes. Maybe this will help you if you are going to college and you may have to take algebra, college algebra. Pretty sure you're going to have to remember these properties so you can do your assignments. All right, let's go to the next. Okay, our next property is called associative. I want to write it neatly for you. Associative. This is the associative property. Okay, what does that look like? The associative property says, let me just set it up for you. A plus B plus C, okay, equals Associative means you associate. That's a root word, associate. So what do you think this is going to look like? So let's rewrite. This is how it looks. Make sure I put my symbols in. All right. So what do you think this is? Uh-oh. I even wrote it wrong. Sorry about that. I gotta have my positive here and my parentheses. Now I shifted the location of my parentheses, all right? So that could be kind of tricky. So now A is here. So that means we shifted or we moved the parentheses for B and C. So now we have A on the outside plus B plus C. Okay? This is called the associative property. So we have in parentheses A plus B plus C on the outside of the parentheses. Now we're separating A plus in parentheses B plus C. So hopefully you can understand it. It shifts. All right. So now let's put in some values. All right. For our example. Put in our values. So let's do 1, 2, 3. All right. So now 1 is going to go right here because it represents A, and B is 2, and C is 3. Now we're not going to evaluate anything, the problem, okay? We're not evaluating the properties. I'm only giving you the properties so you will understand if you had to answer something like this on an exam test and it's multiple choice, you would know what it looks like. They normally ask you, what does an associative property look like? Okay? All right. All right, so this is the associative property. Now we're moving on to the distributive property. And if you have been watching some of my problem solved sessions, you probably know now that I have used the distributive property in pretty much most of my sessions because that is a famous or popular property that they use so many times in algebra. You're going to use the distributive property probably the majority of the time. All right? So let's erase this. Okay. So we're going to the distributive property. I call that the famous property. Alrighty then, let's move on. Let's write distributive. D-I-S-T-R. Distributive. I-B. Distributive. Okay. And you probably see the root word. Let me erase my E. It looks kind of messy. In math, your penmanship really needs to be really, really neat when you're writing it on paper. I know most of you are, in class students. You're probably doing online math, so you probably don't have to write anything. But if you're going to write and take notes, you want to be able to go back to reread your own writing. So please write neat. Your penmanship should be really written well when it comes to math, so you can go back, review, catch your mistakes if you got them wrong. And I always say, if you're sitting next to a computer and you are in class, in college, or with your assignments, please have your tools. A notebook, paper, pencil, pen, ruler, graph paper, whatever you need, because you want to get these answers, these problems correct. And if you're a genius, then okay, you don't need your tools. But if you want to understand and learn your math, if you're pursuing the STEM field, you need your tools. You need to write your problems out so you can see it. And if you miss it, you know where you made your mistake and you won't do that the next time. Alrighty, so let's move on. Went on a rabbit trail. That's because I'm a teacher. All right, so now let's go to the distributive property. And we have used this multiple times. All right, so we have A. And I'm going to write it 3 different ways so you can see sometimes it's written like this. Sometimes it's not, depending on your textbook. So you got A times, in parentheses, A times B plus C. And that is equal to, and I'm going to break this down. I have done it several times in my sessions. So what this says is we are multiplying. We're saying, I'm going to use a dot here, so I'm going to write it 3 different ways so we can see this. I'm using my dot for multiplication. I also show it to you with the multiplication symbol, with the X. X can be confusing because it's used so many times as a variable. So that's why I don't use X, and that's why in most of the textbooks you will not see this with the variable X or just X, because it can be confusing. It throws you off sometimes. Especially when your problems or your expressions become very long, it will confuse you. All right, now that I have it written 3 different ways, this means when you don't have a dot or X, that means multiplication. So that means we're going to take A and we're going to multiply it to B inside the parentheses. So that means A times B, which is A. I'm going to write it this way. AB. That means we can write AB because in the textbook, when you have variables next door to each other, that means multiplication. Okay? So we're going to jump within the parentheses. A times B. Don't forget write our positive symbol. We can't just skip over that. We must bring everything over. Okay? We cannot skip that. So we have A times B plus A times C. All right? So this is equal to AB plus AC. So you see what's common. A is common between your addition symbol. All right? Now, I only showed it 3 different ways so you can see it. Some students may want to write it like this, A times B, so they can remember. You know, if they're just learning this, this is important to students. A times B plus A times C. And now you can see if it's confusion right here. If you say A times B, I'm writing it smaller so we won't think that it's a variable. Plus A times C. Kind of wrote that X smaller so you can see the difference. But all 3 of these are representing the same concept. All right? This is the famous distributive property that I have been using since I've started my problem solve sessions live. All righty? Okay. So let me give you some examples. So I'm going to erase these other ways so you can see it with numbers or constants or values, whichever word you want to choose. Don't let it trip you up. Whatever works for you, as long as you can get the answer and you understand the rules, the definitions, and you have the formulas, you should never get these wrong. All right. So now let's just let me think of some numbers. I love the number 3. So let's do 3 times, let's do 2, and make it simple. Right now we're not evaluating, we're just only showing the process, okay? Equals, now what are we doing? We're saying 3 times 2. So let's write 3. Now, when you're using numbers, we can either use the dot, or I forgot to tell you that we also can represent this with 2 parentheses. 2 parentheses next door to each other also represents multiplication. I think I talked about that in my previous sessions. So if you want to go back and replay that, I think I covered when things are next door to each other with parentheses, it's also multiplication. All right, so let's put 3 times 2. Let me just represent this in a different color. Sometimes colors can make things pop. All right, so 3 times 2 plus, now let's go back, 3 times 1. Trying to be neat here. Okay, so now we have 3 times 2. Now we're we're distributing with inside the parentheses. So now we're going to have 3 times 1. So 3 times 1. Okay, so if you were to evaluate this, okay, if you want me to evaluate, even though I said I wasn't going to do it, but if you need to go to that step and they ask you to evaluate for your final result, they like to use result, or your final answer, or your solution, then this is how we do that. You must know your multiplication tables. So 3 times 2 is 6 plus 3 times 1 is 3. Okay, and when you add 6 plus 3, the answer is 6, 7, 8, 9. All right. So the answer, if we had to evaluate, after you choose which property it is, then the answer would be 9. Okay? Alrighty, let's move on. We have 3 more to go. Hope you all still can see. Can you see? Please wave at me and you can still see. If this is helpful to you or beneficial, please like and share. I hope you are learning something, or just a review, or if the adults are going back to college and this can be helpful, or parents can help their own grandchildren or their children or whomever that may need to review this while they're submitting their online assignments. All right, so let's move on. We're going to, math takes time. That's why some students don't like math, because it takes time to work out problems, to understand concepts. But once you learn it, and if you enjoy it, then this is okay for you. But the majority of students don't like math, but we still have to do it to graduate from high school, to graduate from college. They like to give us college algebra, unless you can test out of it. All right, so let's move on. Okay. Thank you for your patience. If this is something that's really beneficial, this is something that, hopefully you don't mind me breaking every step down, going through it. Hopefully you shouldn't have to ask questions. If you have some assignments, and if your students have assignments and they need help, then inbox me. If I can help them, I will really, try to do that. Okay, so let's move on to the identity. Identity. Wow, we love these words. Vocabulary, identity. Some tests ask you for the meaning of these terms, and you have to select multiple choice with it written out in words. So that's why I'm really big on this, because they like to trick you up sometimes on online math, like My Math Lab, Google Chrome, if they're doing their homework on Google Chrome, or if you're taking Alex in college, sometimes they like to throw word definitions, and you really need to understand that. Okay, so identity. Identity is when you have A plus, look at this, 0 equals. So now you see you have a variable with a constant or a number or a value. So A plus 0, A plus nothing. What do you think this is going to tell me? What do you think A plus nothing is? That is equal to A. Right? Because A plus nothing, if you remove it, if you put your hand over it, it means nothing. So you're left with it equaling, can I say that? It's equal to A. All right? So that's what the identity is for addition. Now for multiplication, and I'm going to use a dot, A times nothing, or 0, is equal to, what do you think? What do you think? Oh, sorry. That's not right. Sorry. What I meant to say is, this is also an identity when you say A times 1. What do you think that is? A times 1 or anything times 1, which I'm going to do an example. Okay? A times 1, what do you think that is? If we just drop the 1, anything that's multiplied by 1 is always itself. It is A. Okay? Want to make sure I got that right in my notes. Just following my notes because I wanted to make sure that I go through this step by step. All right, so let's do an example. So we're going to come over here and do an example. Okay, so what if I have for A, I'll allow A to be 2 plus 0. What do you think that's going to be? It's whatever A is, which is 2. Okay? And here, if I have A as 2 here times 1, that is equal. So 2 times 1, we know our multiplication is simple. The answer is 2. So this is called your identity property. Addition and multiplication. You have 0 and you have 1. And when you give the variable a number, this is what happens. But this is only when you apply 0 for addition and 1 for multiplication. Okay, we have 2 more to go and we'll be done for today. Okay, let me erase this. Please like and share if this will be helpful to any students that you know. Okay, now we're going to the inverse property. Inverse property. What does that look like? All right, so if we have A plus a negative A. Remember, our letters are our variables. Your variables can be from A to Z. You can pick any variable to represent in algebra. Okay? So here we have A plus a negative. So this is A and this is the opposite. This is positive A, negative A. So what do you think that's going to give us? This is equal to 0. All right? And let's give an example. If I allow A to be 3 plus my opposite of positive 3 is a negative 3. So it's like you're saying 3 minus 3. It's really written because I believe in a couple of my sessions, if you go back and replay, I gave you the sign rule that if you have a positive, remember this is next door to the parentheses, that means you're multiplying really. So a positive times a negative is going to give me a negative. That comes from my sign numbers rule, okay? So you're really saying 3, and here's my negative coming down. 3 minus, it changes the term, minus instead of negative. 3 minus 3, and 3 minus 3 is equal to 0. That's what that's really saying. But you have to understand the sign rule. And please, if you go back in my other problem solve sessions, I reviewed the sign rules. I gave them all to you. So a positive, if it's next door like this, positive times a negative is a negative. Okay? So you're really saying 3 minus 3, which is equal to 0. It is the same thing. It's just most time in the textbooks, it's not written like this. Okay? So let's do one more example of this before I go to the other part of the inverse property. Okay, let's use 14 plus, want a different color, plus a negative 14. What are we going to have? 0. It's just saying 14 minus 14, which is 0. All right? Very simple. Now, let's go to the other inverse for multiplication. So, let's erase this. This one was for addition. Now let's do the one for multiplication. That is A times 1 divided by A. Looks kind of tricky, can be confusing, but I'm going to try to break this down, okay? This is saying A times 1 over A. So A times a fraction. Now I need to show you something. The answer with it would be 1, and A cannot equal to 0. We cannot let A equal 0. That means A's cannot be 0, okay? That cannot be in the denominator. Remember, this is your numerator. This is your denominator here, so we can't have 0 here, and anything times 0 is just going to be 0. If you know your timetables, your multiplication tables, okay? So let me just kind of break this down. I'm going to rewrite this. This is really saying A divided by an invisible 1 times 1 divided by A. So you really have like an inverse of this, the reciprocal of this fraction. This is a fraction and this is a fraction. So if we was to cross multiply, you really can cancel, like cross over, like, well, let me try to explain this a little because some students kind of get it kind of confused. Let me do this. Kind of want to show you. Okay, if I write it like this, you can see the inverse, the reciprocal of it. But I'm going to write it like this. A and 1 over A. That's still saying the same thing as multiplication. So if I want to cancel, I can say A cancels with A and 1 cancels with 1. That's why it's equal to 1, because 1 times 1 is just 1. All right? So this equals 1. Because everything is canceled to 1, and when you multiply 1 times 1, if this whole thing turns into 1, 1 times 1 is just 1. So that's why it's 1, but A cannot be 0. I hope you follow this, but you can also replay it if you don't understand it. But sometimes when you're working out, when you go further into Algebra 1 and Algebra 2, when you're solving for a variable, you're going to use the reciprocal thousands of times when you're working out problems. And if you don't understand this concept, if you miss this concept, you don't always have to write everything in detail. If you understand it, you will get the answer. But some students that are starting out don't understand where this identity comes from, how to use it. All right? So let's just do an example. Going to erase this. Let's do an example. All right, so let's do 3 times 1 divided by 3. All right? Remember, I just put my little fraction bar in my invisible 1. And guess what? If I say, let me just write it here, 3 times 1, I can write it like this too. And my invisible 1 times 3. 3 times 1 is equal to 3. And 1 times 3 is 3. Okay? So if you do your division, you got to know these concepts, your basic arithmetic, multiplication, subtraction, addition, division. So if 3 divided by 3 is equal to 1. Now, I know this is simple, but if we come back over here and we do long division, 3 divided into 3, what times 3 is going to give me 3? It's going to be 1. So 3 times 1 is 3. We subtract it. Our remainder is 0. So our quotient is your answer for division, is 1. So we don't have to write a remainder for long division unless we go back to basic arithmetic. All right? So that's why, I'm going to erase this. That's why I wanted to show this concept with using numbers, because you can see now why the answer is 1. You're multiplying straight across, or you can cancel, and you're still going to get 1. All right? Okay, we have one more to go, and we are done. Okay, so this is your inverse for addition and multiplication. Alrighty. If you're getting bored, I know math can do that to you, because math takes time. If you don't have any patience and discipline, you won't get through your math classes, because it takes time to work out problems. Okay? So, all right, the last one is called the multiplication property of 0. Multiplication property. I have to write this out so you'll know the difference. Property of 0. I'm just going to write it here in the word, okay? Multiplication property of 0. What does that look like? That is just saying A times 0. And what do you think that is? Anything times 0 is always what? 0. That's anything. So I can have 1 times 0. You know your 0 multiplication. 1 times 0. Any number. I'm just going to use pound to represent my number. Any number times 0 will always give us nothing. If you're working with money, any money, $2. If it's times nothing, it's going to give us 0. We don't want that, right? We want to multiply and increase, okay? All right. My Facebook students. Just want to make sure I'm looking at my notes here. We covered all of the algebraic properties for all real numbers. And the very last property that I went over, it may be different in a book, online, however they have it, you need to know these properties. So the very last one was the multiplication property of 0. And remember, any variable, any constant or number times 0 is nothing. 0. Alrighty? I hope you all are healthy and safe. Hopefully you can replay this and like and share and take your time, and hopefully students out there learned something today. If you haven't, and this is something you already know, pass it on to someone that may need it. So please like and share. Peace, be healthy and safe. All right. Hello, Verlinda, Leonard, Terry. I appreciate you all and Tina enjoying my lessons. I try to come on at least, Monday through Fridays, hopefully. I have a lot that I'm working on, but I'm trying to give back to the students that are quarantined at this time. And I hope, this is very beneficial. I'm trying to go over many of the concepts over the years that I noticed that students forget about, they don't know, or it's kind of overlooked. And hopefully this will be beneficial during this time. All right, so I'm saying peace out. Thank you all for watching. Please, please like and share. We want to share the love, okay? Bye-bye.